Okay, in our previous segment, we discussed what the acceleration due to gravity was. So it is going to be an acceleration that you're going to be feeling right now if you're on the surface of the Earth, or even if you go like 10 miles up into the air, the G is still going to be around 9.81. So you have to go up really, really high into the atmosphere before G starts to change appreciably. So we want to come up with equations that are going to tell us what is going to be your speed when you're going up and down, and then what is going to be the distance you're going to travel when you're going up and down. So all we've got to do is take our ordinary equations up here, which we used for horizontal motion, and then substitute into them G. So instead of the letter A, we're going to put the letter G into all three of the equations. And so that then is going to be our equations of motion when things are moving up and down. Don't forget, though, that G needs to be a negative number. So you have to have a negative 9.81 whenever you put them into these formulas here. So here is a sample question. So this kind of reminds me of an old TV show called Lassie, and it was about this kid, Timmy, who owned a dog named Lassie. And the thing about it was that Timmy was always falling into a well. And then he'd be in the middle of the well and he would say, "Lassie, go get help." And the dog would go tromping off and would go find the parents and then bring him back and pull Timmy out of the well. Well, actually, I don't think that ever happened in the TV series, but it stuck. So let's say that Timmy is stuck in a well, and we need to know how deep is that well. So how could we do it? So example number one, a rock is thrown into a well. The splash is heard 2 seconds after the rock is dropped. How deep was the well? So we're going to take our rock, we're going to put it over the lip of the well, we're going to drop it, 1 Mississippi, 2 Mississippi, ow! So that was the sound of the rock hitting Timmy on the head down there. I'm sorry. So nobody got hurt in the making of this episode. But anyway, you get the idea. So that you hear the splash of the rock when it hits the bottom of the well. And so we're going to use that in order to figure out how deep the well is. So which formula do you think that we ought to use? Well, we're given T was equal to 2 seconds, and we were trying to figure out how deep is the well. So how far does the rock travel before it hits the bottom of the well? So looking at our formulas, notice that we cannot use this equation right here because notice it doesn't have the letter T in it. So you can't use it. Okay? And we're looking for how deep the well is, so it's got to be a formula that has the letter R in it. And so that's going to be this one. So this formula is not going to work. So that's why it's so very, very critical to write down what you know, because then that can help you to figure out which formula to use. And then there is another piece of information that is not specifically given in the problem, but it's very important. Can you figure out what it was? Okay, we're going to write down our equation. How far the rock falls is equal to the initial speed of the rock, and then it also depends on gravity. But what was the initial speed of the rock? It was in your hand before you dropped it. So the initial speed was 0. So that means that this part of the equation is not there. So all that we've got left is that we're going to say that the distance r that it's going to travel is going to be 1/2. Okay, now I'm going to go ahead and put in that negative 9.8 thing. Actually, negative 9.81. Okay, and then times t squared. But the t was 2, so we need to take 2 and then square it. And so that ends up being negative 19.6 meters. But what's the significance of the negative in negative 19.6? It's going down. So do you remember that when you go down, you use negative numbers, and when you go up, you use positive? So that just means that it is 19 meters below the starting point. So if you want to call where you dropped the rock, if you want to call that 0, then it fell 19.6 meters. So that's what it means. Another way of thinking about it is that the r was also a negative number, because the distance going down was a negative, and so the two negatives would cancel. And so then you would end up with a positive distance that it traveled. Here is a more conceptual type of question. An arrow is going to be fired straight up, and it has an initial speed of 50 meters per second. Explain how you would calculate the time it would take to reach its maximum height. Okay? Now, the very first thing that I tend to do when I don't know how to solve a problem is draw a picture to go with it, because maybe that will jog my memory on how to do it, and at the very least you might get some partial credit when you take the exam. So this will be the ground, and then, I don't know, the guy's laying on his back. So let's say the guy's laying on his back and he's going to shoot the arrow into the air. So the arrow's going to go straight up, and then it's going to come, well, maybe we need to put it at an angle. All right, so we don't want him to get shot. So it's going to do something like that. So if he shoots it straight up, it's going to come straight back down on top of him. We're getting violent enough in here, so we don't need to do that. So let's label on the picture here. It says that it was shot with the speed of 50 meters per second. Now, what sign should we put on that? Should that be positive 50 or should it be negative 50? It ought to be a positive 50 because it's going up. All right, is there any other pieces of information that we might want to put on there? Okay, so this is going to be velocity. Which velocity? So we got two of them, initial and then final. So which velocity is this one? This one's going to be the initial velocity. So in most of the problems that we've been doing, we've been assuming that the initial velocity was 0. Now, what about up here? So at the top of its trajectory, what could we say? We could say that it has a final velocity of 0 meters per second. What would have happened if it got to the top of its trajectory and it still had speed? Well, it would keep going until its speed did get to 0, and then it's going to start to come back down. All right, now, are we given the distance that this thing is going to go up into the air? No. So we cannot use this equation right here. It won't work. But we could use this one. So this one says that your final velocity is going to be equal to your initial velocity plus gt. So we do know what the initial velocity is. We do know what the final velocity is. And we do know what the acceleration due to gravity is. Don't forget, negative 9.81. So that's the number that you have to plug in here, because gravity is pulling down. Otherwise, if the gravity was up, then this thing would just keep going up forever. And as a matter of fact, it would be accelerating as it went up. So now we've got this one, we got this one, we got this one, and now we could solve it for this one. So I will leave that up to you. So you can go ahead and solve that equation for the letter T. And once you've got that, can you see what you could do? You could take the T and then plug it into this formula and solve it for the distance that it would travel. Or for that matter, you could use this one. So this one has the distance that it would travel. So you could use either of these two equations now in order to figure out the height that it would go to. Also, could you tell me what speed would it have when it hits the ground? So it starts with 50. When it's at the top of its trajectory, it's 0. What's its speed when it hits the ground? Now, assuming no wind resistance, it's going to be 50. So it's going to have the same speed coming down that it does going up. The only difference is it's a negative 50 because it's going down. So whatever speed it's got right here, so let's just say that it's going at 20 meters per second, it has negative 20 meters per second over there. So that's something that we use quite a bit in physics, is symmetry. And so we can solve some kinds of problems by using that technique. Okay, let's take a break, and when we come back, I'm just going to mention trajectories. But we're actually, in this class, we're not going to do anything with trajectories, but I want to mention it to you.